Hello, welcome to Enlightning, the first one of 2024. So glad to have you here, and so glad to have you here, Ben. Thank you so much for coming on today to teach us about Kubescape. Tell us about yourself.
Hey Whitney, I'm really happy, really glad to be here. Actually, I following the show and I think it's a great format.
Thank you.
And again, I'm also very happy to be here, the first guest, in 2024. So a little bit
Good.
about myself. Yeah, sorry.
I was going to say, got to make you a t shirt or something.
Yeah,
Yeah.
yeah, yeah.
A medal. I don't know.
Maybe it's a good idea for the guests. I'm just saying. Uh, um, I'm Ben. Those who don't know me, I'm active in the CNCF security scene for some time now. Originally, my background is offensive security. I'm close again to 20 years of experience in the industry, which is a little bit hard to say and strange. Yeah,
You have the 81 as part of your
yeah,
username, so I had a
yeah.
guess.
It's a hint. It's a hint. Yeah. Um, but yeah, I for many years been working in the offensive security field.
What does
And
that mean, offensive security?
so, like usually when security practitioners are talking to each other, they are saying that okay, whether someone is in the offensive or on defensive side. So
Okay.
defensive side is like most of the people who are like building systems and trying to protect them, and
Uh
the
huh.
offensive side is all the others who are not trying to protect a system but trying to break in or
Okay.
trying to find vulnerabilities and exploits on systems. Uh,
Okay.
so so many years I was on working in companies were involved in testing their own products and their own systems, and they were hired to test other companies' systems to find vulnerabilities.
Uh huh.
Um, and gradually, I've moved into the defensive and product side.
Okay.
Um,
That
so
sounds fun. Is it fun to like try to break some? Do you like feel this huge rewarding feeling when you break
it,
into the system?
it's yeah, it's like you remember the movie Matrix, right? And
Uh
when you get in, you feel like now you're starting to see the bits, like right. So yeah, it's very rewarding. It's but after a while, like many other things, can start to be a little bit repetitive,
yeah. Yeah.
maybe.
I
And
can relate.
having said that, I'm not doing it here a big disclosure, but next week you'll see that I'm still here and there trying to break into things, and we'll publish hopefully next week or the week after some interesting news. Um,
Oh,
but,
exciting.
but here and there, I'm still like to touch things and take try to see how they are working, and this is something still very close to me. And I think that one of the things that a good security practitioner, even on the defensive side, has to know is really how things are attacked and what an attacker is thinking.
Yep.
And I was blessed, in my career that I when I went into the product side of the world and the building up side world, I had like not few, many years of experience,
Mm-hmm.
and um, yeah, and afterwards I've worked at a company called NDS and then Cisco, where I built different security products on different levels. I was a senior tech lead, then became a CTO like thing in um, one of the departments, and I myself teaching information security for postgraduates here in Jerusalem. So I'm involved also in the academia, and I have a few patents around cryptography as well. So from the curriculum, I did a lot of things in the past. In my past experiences and past workplaces. And today I'm a co-founder and CTO at Armo, which is a cloud native security.
Cool.
And open source was always a very, very a thing which was very close to me always through my
Uh-huh.
whole career. And we've started the Kubescape project. I think 2.5 years ago.
Uh-huh.
And today Kubescape is a CNCF project, and we are hopeful
Yeah.
we'll get, fingers crossed, we'll be in incubation by the end of the year. But
Ooh.
I'm just hoping, like,
New Year's resolution. Yeah.
yeah, it's something we are trying to achieve this year.
Cool.
Um, and yeah, this is where I am.
That's awesome. Oh, I'm so psyched to talk to you today. And those who are tuning in, will you please say hello and where you're tuning in from? And also, I'm interested in those of you, some people who know me might know I host another show called You Choose on the DevOps Toolkit channel. And we're starting a chapter on security. So we plan on doing episodes around every CNCF security project where the security projects only get 5 minutes to present, and they're grouped together as in similar projects so we can understand like what's different about different security projects. So I personally am starting the journey of learning all the different security aspects. So I'm learning, like, you have to worry about securing at the application layer. You have to worry about securing the infrastructure. You have to worry about securing the network. You have to worry about securing runtime. And that's even, there's access control. There's image signing and scanning. Like, there's so many aspects of security. It's honestly really overwhelming when you're getting started. And I guess I don't, so those of you who are tuned in, I would love to hear what tools, like any security tools you're using. And I'm also interested in, I guess, how do you have maybe this, how do you have confidence that your whole, that all of those areas are covered by the tools that you're choosing? Maybe you hire like an offensive person who's actively trying to break your stuff. Yeah. So those are the questions, I guess, for the folks who are watching, but also for you, Ben. I think I'm going to start moving over to the Lightboard. So maybe you could tell me, maybe we can talk about like what security is natively in a Kubernetes cluster before you add any CNCF tools or any add-ons, and how robust is that? What would happen if you just roll with a regular Kubernetes install?
Yeah. So I think it's a very good question. So I think that one of the things I'm always telling about Kubernetes, that people are saying that well, I need to add this and that, and I need to have a mesh for encrypting my data between the workloads, and I need a secure key storage, and I need I don't know, a runtime monitoring system for that, and these are all true. But I have to tell you that if I'm looking only on Kubernetes itself today, Kubernetes, as opposed to many other systems, and especially open source systems before that were built in the previous years, Kubernetes was really built with a lot of security mindset from day one. So in general, if you are looking into Kubernetes coming with a rather robust system and infrastructure level support for many security features, which are mostly, they are covering, obviously, Kubernetes itself. So just giving you an idea of the simplest things of user authentication and authorization. Authentication was from day one, mostly day one, the TLS based client-based authentication, which is a very strong authentication method, was supported. RBAC, which wasn't there from the beginning, the role-based access control in Kubernetes was added rather sooner than people thought, and it's a major way to manage roles and access in a Kubernetes cluster and the API server. But I can go into like the connection between the different Kubernetes components, like the API server, and the kubelets are the one who are actually running what we call the Kubernetes node, which is the VMs behind, the node, and kubelets have been built with a lot of security built in for protecting, obviously, their own area of expertise. But there were a lot of things which were included. The idea of adding what is called the Kubernetes secrets.
I'm going to interrupt you and say hi to some folks who are, we have Kurmaju here, who always asks really good questions. Hi, Kurmaju. And then we have Thindel, who promises that they can unsecure any platform. I think this offensive security idea is it's so good to see you, Thindel. I'm so glad you're here. My code is like a sieve with a hacker attracting flashing light behind it. To quote Anakin, you underestimate my incompetence. So
but I do think that we have that, like the comment you just put up, thing that's the most secure platform is only secure until I put something in it, is like one of the best comments I've seen for a long time. It is so true.
And then hi again, Happy New Year, Kurmaju, and hi, Code with Sean. Thanks so much for being here. All right, I'm sorry to interrupt. I just had to say hi to everyone.
No, it's awesome. So Kubernetes already thought of prepare a lot of things into their architecture and into their offering, which are helping the practitioners to build a secure cluster and secure system. Just an example of Kubernetes secrets, which is like a way in Kubernetes to manage the secrets which every application needs in order to work. And they are really trying to give all the things that the people need for a basic setup. But obviously, if I want to put my security at a higher level and trying to be more, for example, better secret management, there obviously are projects which are trying to cover that. So it's a little bit beyond the scope of the Kubernetes project. So if I want to summarize it, Kubernetes was really built with a security mindset. And if you're following the standard installation procedures, your infrastructure is rather set up well for basic for basic installation, as opposed to many other projects. But if you want to go into a real production system which has a real, I would say, potential of being attacked, then obviously you have to start to build up a more serious security stack.
That makes sense. Especially as you add more and more tooling, you need to add more and more security to cover that extra tooling you're adding. That, yeah.
Absolutely makes sense.
Yeah. So we're here. It's time. We have our blank canvas in front of us. What do, as someone who's new to the scene, what problem is Kubescape solving?
So Kubescape, so I'm going to tell you a short anecdote, and I hope you will have enough time also to talk about the specifics. But the way Kubescape started is that in 2022, NSA and CISA came up with a famous document they wrote about Kubernetes security, and I think it was a major step because if such a government agency is putting its eye on Kubernetes, it means that this thing is happening. Like Kubernetes is security is something that it's going to be its own subject, own category, and they put up this huge document of how people should set up their Kubernetes cluster and what are the hardenings they should do. And first, that was 2 years ago. It was the first version, and ever since, I think that we saw 2 more versions, if I'm not wrong. I think every year they're updating it, and it was the first very practical guide from from a government agency, which we started to talk about how to secure Kubernetes cluster.
Okay. And
we,
what agency put this out?
It was NSA and CISA.
Okay.
And the point was there that sure.
I just want to say hi to Clara. Hi, Clara. Thanks for coming. Good to see you. We're talking about Kubernetes security. All right.
Yeah. So so we thought with a few friends at Armo that like we were really happy about this document coming out, and we said, how nice it would be that I would just like check my cluster against this this document, like trying to create an automatic testing for whether I'm standing in the best NSA best practices framework, like NSA as a national security agency, and we were like, we took I think a few days to build the original version of Kubescape. And we used another CNCF project, which I know that you know very well, OPA. We used it to define rules or policies. We implemented in the Rego language the actual predicates, of whether a workload is defined with a privilege flag on, or whether the API server using RBAC, and we created these questions and built it into a CLI tool, and we called it Kubescape, which is what was kind of funny because we like everyone had a different idea how to call it.
And you called it Cube what?
Kubescape. Like
Kubescape. Okay.
Yeah, well, like we had different ideas how to call it, and but I don't remember why someone chose Kubescape. And it became a brand. So we didn't really associate a lot of importance with this. So we've released it on GitHub. And like in the stories, we went to sleep for the weekend. And a few days after, one of my friends is calling me and say, "Whoa, what have you done?" I said, "I don't know. What did I do again?" And and said, "Well, you have like your GitHub is like just exploding." And I said, "Wow, I don't know." And like we had like within a week or two, we had already 500 stars on GitHub, and people started to use Kubescape really to if I want to use the official language for checking their Kubernetes security posture, so validating whether their Kubernetes security configuration is on par, on level with the requirements of NSA, and try to find where they might have I would say maybe misconfigurations or suboptimal configurations from a security perspective. And this is how
NSA is National Security Administration Agency. Okay. And by national, are we talking about the U.S. government?
Yeah, about the U.S. government. Yeah.
Okay.
So and this is how Kubescape started. We understood really well that this is something that we touched nerve here, something that people are finding useful and interesting, and it's really someone who is starting in Kubernetes security. It's a really good starting point, like trying to understand the basics of how you are setting up your cluster securely. How you can check whether your workloads were defined securely against the best practices. And in the project we decided that as a first step in the first, I would say, 2 years of the project, we've been really trying to solve the problem of Kubernetes security posture, not just from the configuration point of view, but also from vulnerability point of view. What kind of vulnerabilities are there in the Kubernetes cluster? And And I think that up until like this summer, mostly what we were doing is like covering your Kubernetes security posture needs in the project. So configuration scanning, image scanning, trying to find vulnerabilities in the cluster, and not just within the cluster, but also in your CI/CD pipeline. So if you want to set up like GitHub actions to make sure that you are not entering new vulnerabilities and new risks into your cluster. So you could use that, and this is
So I'm hearing a lot of different aspects of security as part of this, and I want to capture that. But before I write that down, what I want is like a definition. I think of like maybe it's hard to define Kubescape because it seems like it does rather a lot.
Yeah.
So what's a succinct definition of Kubescape?
I would define it as a Kubernetes security posture platform.
Will you describe the word posture to me?
So the posture is actually trying to security posture. I would say it's something when you're trying to find threats in your environment. So security posture is actually showing you, putting you in front of a mirror, where the mirror is showing you, okay, what an attacker could use here, what an attacker could go after, what can be a path for an attacker to go into your system, or what are the suboptimal states in your environment, maybe configuration, maybe setup, maybe communication, vulnerabilities, which can lead an attacker to penetrate our system, or if he already penetrated the system, enables it to take, create more damage.
Okay. So we repeat, now that I have a better idea of what posture means, we repeat your definition.
So posture is a way to security posture is a way to show your risk and threats in your system. So Kubescape is there to find whether you have different risks and threats in your system.
Tool to help you discover
threats,
risks in your system.
Yeah.
Would you say it's comprehensive? Probably that you wouldn't want to, because that would make you liable.
Yeah. It's again, it's very it's a very complex definition of if I want to be a comprehensive. So I'm looking at the comments, and I already see that people are talking about code, and obviously, there is a lot of things also to talk about the secure software coding and software exploits and so on. But I would if I need to define Kubescape a little bit better, it's for it is a tool that helps you discover risks and threats in your system, and mainly designed to work together with DevOps teams and DevSecOps teams. So it is mostly touching all those areas which they are touching. So this is if you want to close that box somewhere and not leave it open. So this is how I would say that that's something that is helping the security practitioners around the infrastructure.
So I could add in this box. I'm going to add more after the box. Let's
Sure.
I think I'm going to close this box, and then maybe we can get into specifics into. So there are a couple of things you said that I thought was interesting. I thought I liked that you said it's a good starting point for security, and then it's meant to help DevSecOps teams or DevOps teams. So those are more like softer things. And then you said more specifics, like, oh, you could find vulnerabilities. It helps you with your RBAC. It helps you with this. So I see two directions. I want to go both ways eventually. So let's say good starting point. I'll say good security starting point. I like that. So basically, it helps you see what's wrong, but it doesn't help you fix it necessarily.
So it's partially true, because we are people who are also doing this day by day, and we are trying to build a tool which actually also helping us to fix things. So I'm trying to give you two examples of how it helps you. It can't always help you, but in many cases, yes. So in case of configuration problems, it can really point you to the specific configuration fields that causes that risk. So you, as a practitioner, you are already focused, and you don't have to start to find yourself these issues and the root problem of root configurations. This is one thing. And another thing, which is I'm kind of I'm proud of, is also the way that we've added this year capability to filter out security issues, vulnerabilities in your system that are not really exploitable. So we are trying to filtering out a lot of noise of false positives in your system.
Okay.
And this is something that is very, very close to our heart, because again, as security practitioners, we hate to work and just find out that the things which we are working on are not really problems. So it's something that we are really working hard, and we'll work even more harder. But I think that we're not just trying to say that, okay, there might be an issue here, but we're also trying to filter out, as opposed to many other projects, the results.
So under the good security starting point, like, it helps solve security configuration problems, it helps filter out false positives, and then I'm inferring that it would help you then identify bigger problems that you would solve with additional security tooling. Is that accurate?
So define what is greater problem. So
yeah, I think that's what I want to get into next, is more specifically like all the different areas, like all the different things Kubescape can do. Right now, I'm just thinking, what things make it a good security starting point?
So the things that I think are making it very a good starting point is two things. One is that I think it's very easy to start to work with it. So it's like the entry
easy to use
is very easy to use. Install easy to use and integrated with many things. So it's very easy to put it into your workflows if you're like practitioners around these things. And I think that the second thing is that it's really, you're right, it covers a lot of aspects, as opposed to many projects. It tries to cover a lot of aspects, and what makes good that it gives you a comprehensive picture. And maybe it's not a full picture, because anyone who claims who have a full security picture, everything is I'm trying to look for the right word here, but is not always true. But I think that we are covering a lot, so it's also a good point, because getting a big picture here. So it makes it.
And we have a question.
Yeah.
Our first question of 2024 is from Koramaju, which is fitting. Threats like ransomware, right? Can you please give some examples of what kind of threats have you seen so far in a Kubernetes environment? If you see some threats, how would you eliminate them?
So let's start with, let's start actually with what are the threats on Kubernetes environment, and I want to put the ransomware at the end.
Okay.
So there are multiple threats in Kubernetes environments. If I'm taking the example of many people are running, Kubernetes in managed environments, like AWS, Tanzu, GKE, AKS. These systems have a default setup which is which is rather a good setup from a security perspective. All these are coming with the basic settings are really tuned to a good security. I think that there are two main threat vectors into Kubernetes today. One is supply chain security or supply chain direct. So I can, like, as an example, I can give you the SolarWinds attack. Anyone who's following what's happening in the cyber world in the past years knows about this attack. So the idea was that the attacker or attackers managed to inject their malicious code into the software in its building process, and anyone who wanted to use that, anyone who was relying on that software or the software packages, have pulled the software packages through the internet and started to run them as usual for their usual operations. And it turned out that the software included malicious code, which was used for, in that very specific case, it was used for espionage, to listen to information, take and send information out of the systems. So this is what we call supply chain attack. So when I myself is not, like, I'm being attacked through the way that I'm trying to use software, and that software is already infected with some kind of a malware or malicious code. This, by the way, it's very similar to like from 20 years ago, when we had all these PC viruses and we downloaded software and started to run it, and like, actually this was the very same idea. Now, this is one threat on Kubernetes clusters. The other threat is actually vulnerabilities. So if an attacker, and let's say an attacker is not an insider attacker, it is someone who is trying to attack a Kubernetes cluster or services inside the Kubernetes cluster, it will try to find a way to get, to the vicinity of the Kubernetes cluster through network, right? Because it is not very practical to go into the data centers of your cloud provider and penetrate them physically. So the way that people are trying to go into Kubernetes clusters, attackers, is through network and trying to find vulnerabilities on endpoints that are available for them. So this can be both maybe the Kubernetes control plane endpoint, which is an attack vector, and another attack vector is actually all the services which are exposed from the Kubernetes cluster to external networks, and this is the second way. So I'm just, again, getting back to the original question. So just a very naive answer to that is, if you have a service, you have to publish to the external internet, because actually this is your service you are trying to provide to the public, and that service has a code injection vulnerability, meaning that on a specific API call, the attacker can inject a command which will actually be run by the workload. Then you are under a big threat, right? Because someone can, from the public internet, can come to your cluster or to a component inside your cluster, and can penetrate it by running arbitrary commands on your Kubernetes workload, which again, we started by multiple layers, right? Because the workload is a containerized application, it has limited access to what is happening in the node, and there are multiple things which we are going into in a few minutes, I hope. But these are the main two attack vectors today.
Okay.
And I would touch them. Obviously, I'm like, there are very, very obvious attack vectors. Like if you are publishing your AWS access keys, which are giving advice to anyone, it's an obvious attack vector. Okay, and it's not very Kubernetes specific either. So these are the two main attack vectors, which I would say that the main things to attack. So to get to the question of ransomware. So the question is that, like, a ransomware is getting into the somehow. So I would say that these are the two ways I think we should discuss at this stage about how a ransomware can get into a Kubernetes cluster. So either by contaminating a supply chain, something in the supply chain, and this is the way the attacker is able to run code inside the Kubernetes cluster, and then ransomware would try to find data and encrypt the data and try to remove or disable the connection for the user to the data so they can ask for ransom. Or through a network vulnerability. Again, this is not a very comprehensive answer, but these are I would say that these are the main things that are worth saying, because again, if someone steals your administrative password to your cloud API, I would say it's a very very straightforward thing and not very interesting. And I think that all of us know that this is something that needs to be handled.
Excellent. That's a great question. Thank you. And thanks for the good answer. And now, if you're ready, let's jump into all the aspects of what Kubescape can do.
Yeah.
Like a nice overview, because it seems, based on everything you've said so far, it seems like rather a lot. What would be a good heading for this section? Everything Kubescape can do.
Yeah, so everything Kubescape can do for you.
Okay.
Yeah, but maybe it won't be that long list, but I think it's an interesting thing to go in. So,
okay, I'm listening.
Kubescape is covering, I would say, the scanning of your Kubernetes infrastructure setup. So how your API server was configured, how your kubelets were configured. If you are running in a managed Kubernetes cluster, we are also trying to connect your cloud provider API to see whether you're using the best configuration you can. So we are scanning your Kubernetes infrastructure setup, and it's although it's a static thing, and this is why, when you remember, Whitney, that you asked me whether we can help you with showing you how to fix the problems. So for example, this is the way where we have, like, we can point you to things how to configure them, but it's something that's very very sometimes very specific to your specific setup. Therefore, we can give you only pointers and not solutions usually around issues. So to give you a few examples, we can validate whether you're using TLS in between your control plane components, whether you configure the API server with the proper setup of enforcing TLS and enforcing authentications. So these are the kind of things, or whether your Kubernetes secrets are actually encrypted in the etcd, which is a configuration that the API server has. So so these are these are the very basic things at the infrastructure setup level. Beyond that, there are two main areas for scanning the configuration. One is scanning your workload configurations, which is one thing. I'm giving you an example. I think I might already told that, but think about when you're scanning, when your workload is running in root user or not, which has its own security effects. And I'm just like trying to connecting for all the listeners the dots here. So if I'm running my container as a root user, it's not a vulnerability that an attacker can directly use, because in general, the attacker shouldn't be able to use that kind of privileges because he shouldn't be able to control what the workload is running, whether it doesn't matter whether it's running in root or not root, but it's a risk. And I tell you why. Because when the attacker is able to penetrate the workload, either by the two threats you've mentioned above, you wrote above, it really matters whether your container running as a root or not, because it makes a difference on where the attacker can propagate or continue its attack. And a real world attack is never a one-stop shop. Like it's always there are always multiple attacks and multiple stages involved. And running workload as root has effect on what kind of what is the access at the file system level, what files it can touch and change. Yeah.
The file system level. Got it.
Yeah, sorry. So whether if the attacker is able to penetrate a workload, whether what the attacker can do at the file system level, and also what it can do, what kind of requests and operations it can do with the Linux kernel. So these are the two main things, for example. And this is just there are, I think that we are checking more than 10 or 15 aspects of the workload configuration. So I'm really trying to give here, a few examples for you to start with. And again, for example, this is a complex problem because it would be like very great if all the workloads, all the containers would be running without root permissions. But the thing is that the way that Docker started and Docker built up the ecosystem around containerized images, everything was by default root. And when your defaults are root, then in many places will start as root. So I don't have very specific statistics, but I would say that overwhelming percentage of all the pre-made container images we see today are built for running them as root, and it's a problem to make them not running as root. So this is an example of a workload configuration, and the last around and not least, from the configuration scanning is your RBAC, your role-based access control configuration, which can be sometimes a little bit overwhelming, again, because there are a lot of definitions and understanding that what are the roles that, for example, in Kubernetes has access to secrets, or what roles have can execute into workloads. So these are kind of things that reviewing them and making sure that only those who are really need access to these things is a really important thing. And managing RBAC and finding out that the roles are assigned to all those who need is important in the Kubernetes security field. Yeah, wow. I love that you use the least privilege.
I'm learning.
Yeah. So go on.
I think there's an echo. I think I'm coming out of speakers. Okay, great.
Okay.
We're fixed. Yeah.
So these are the configuration side. Now let's talk a little bit about what Kubernetes can do. Kubescape can do. Sorry. So we are scanning the workloads for vulnerabilities as well. We are using
So wait. So Kubescape can do a lot, and we talked about these things it can scan. So it's and then what are you telling me now?
So
how does that fit with this?
No, this is another capability of
a fourth
Kubescape.
one.
Yeah.
Okay.
Fourth one, and if you want, I'm trying to think of what worth mentioning here, because we released some new features. I would say two more.
Okay.
I would add. So the one is vulnerability scanning. So reporting vulnerabilities in your workloads. So if you are or the listeners are know projects like Trivi, like Gripe, like Claire, so we are doing somewhat the same. We are scanning for well-known vulnerabilities in your workload, so you know that what vulnerabilities you have in each of your workload images.
Okay, I think you just answered my question. I had a question that was maybe a silly question, but scanning a workload is the same as scanning a container image.
So so in, for example, in the CLI, we've connected these two things. So because I'm as a practitioner, I'm interested in both, right? So it is like one aspect and another aspect, but both of them are related to the workload. So it really depends on how you are, what you're working. To be frank, I see that in the industry, sometimes these two definitions are simply split between two different functions in a company or in a security team. So there is someone who is dealing with the image vulnerabilities, and there is someone who is dealing with hardening the best the workload configurations. But sometimes it's the same person.
Okay.
So this is something we are doing, and we are working this year in 2024, and already started in the last 2-3 months on helping you how to harden your environment. So giving you hardening proposals. As we talked about the word posture, right? So you have so the word posture, which is like again, I agree with you that this is like a hard word, but again, if I'm saying that you have a potential attack surface, in your environment, a potential way of attackers of getting into an environment and exploiting things. So when we are trying to shrink this attack surface, like trying to remove things from the potential of being exploited from, we are getting from the attacker these things and taking this away from them, we are calling this hardening. And sometimes it's a very hard and tedious job to do because you have to check a lot of things. In order to, even if you know what you're trying to achieve, it's sometimes really hard not to break the applications, because, and I'm getting to your definition of least privilege. The reason why least privilege is not very common, because it's really hard. So any security practitioner knows that the least privilege says, right, that you're giving to everyone the minimal privileges in order to achieve their work. But it's hard, because if you are like giving a little bit less than they need, then they cannot work, right? So it's, by instantly, most of the time we are over privileging people, not to block them from doing their job. So hardening is hard. So we got to the conclusion that the way we can do it is actually we have to start to look deeper into the Kubernetes cluster or in the workloads, and understand a little bit better what are the actual privileges the workloads are using in many aspects. So and came up with the idea of trying to give proposals of remediation proposals to the users based on their actual usage of the Kubernetes cluster. And
okay. So we're talking about the fifth reason right now, right?
Yeah.
Will you restate it for me?
So we are giving you hardening or remediation proposals or recommendations.
Oh, nice, cool.
So the nice thing about it that it is tailored to your application behavior. So just giving you an example. So you talked about with Duffy about network policies, right? But network policies are sometimes a little bit hard because network policies, again, least privileges, you have to know to what to give access to in the network, to which workload to give what access. And it's hard because you don't either you are expert on that specific application, and now you start to write and hope you're not forgetting something, because if you're forgetting and you're setting a policy which is breaking something, then you're not in a good position. But think about if you have like 200 of these applications, and it starts to be a problem that doesn't really scale well from a security practitioner's point of view. And we started to connect with another CNCF project called Inspector Gadget. And they are experts in the field of eBPF observability.
Okay.
And we are using their observability data to give you tailored hardening proposals to your environment. And I'm getting back to the example of network policies. So think about it that I can monitor your Kubernetes cluster. I can monitor with eBPF your workloads and see at the network level which workload is talking to which one actually. And say, look, Whitney, I can tell you that workload A needs to speak to workload B and C, and that's it. Now I can give you a proposal of network policy based on based on actual real data.
Cool.
So it's something that we are like a big believers, and there are things which we already doing with the Inspector Gadget guys for more than like 6-7 months. But there are new things which are coming out. Network policy came out around KubeCon, and we are going to release in the next few months more of these kind of proposals, and these are the last thing I would say that which we are good for today.
So an example would be a network, like it would give you an example of a network policy you might want to implement.
Yeah.
Okay.
So it would give you a network policy proposal, and you should implement this because this is a least privileged network policy based on your application behavior.
Oh, I like that better. Least privilege network policy proposal. Cool. So that leads me to another question and that I kind of had in my head before, which is when you were talking about scanning in particular, and you mentioned Trivy, like there are a lot of technologies that already do scanning. So I guess, are you using those technologies under the hood, or in cases where this can be done with another technology, are you just are you building your own solution, or I guess what other technologies are you working alongside?
So so from the configuration scanning side, we are using our own rule engine.
Okay.
I mean, sorry. So we're using OPA, which is the rule engine, and we are writing our own rules.
Okay.
I can say that we, from a Kubernetes perspective, I think that we have the most comprehensive rule set, policy set, as of now, which includes not just the NSA recommendations and MITRE Microsoft recommendations, but also we have a lot of compliance frameworks which we can help you with. From a configuration scanning point of view, this is what we are using. From a vulnerability point of view, we are using actually a vulnerability scanner project called Gripe, which is an awesome project.
Okay.
And we are enriching their data. They are giving us the basics, which is, I know it might sound like a small thing, but they are doing a huge, heavy lifting of the work with the vulnerability scanning, and it's called Gripe, the project.
GRIPE.
GRY.
Gripe.
PE. Yeah, Gripe.
Okay.
And from taking the eBPF information, we already talked about, we're using Inspector Gadget.
Mm-hmm.
So these are the things which we are giving. And again, we are. I think that as a project, we are in a sensitive place, in the sense that we don't want to rewrite things that others are already doing, because it's not very interesting. But we want to be able to make much more sense of the data, because we usually tell each other that we don't want to give data to the users. We want to give information to the user. And we are using all these data streams to come up with the better results and better information. And this is how I would define the philosophy of the project.
I love it. It makes a lot of sense. And we have another question from Kormaju. If we use Kubescape on Kubernetes, on a Kubernetes cluster, does it overwrite the default secrets in the Kubernetes environment?
So it's not really. We are not really touching the secret management part, in the sense that we are not trying to make Kubernetes secrets better. Like, you have actual tools. I would say the staple is HashiCorp Vault, which is somewhat external secret management tool, which is a great project. We are not trying to tackle that problem. Therefore, we are not really touching existing secrets, but we do show you who has access to secrets, who can, what the meaning of these access to these secrets are. So again, we are more of touching secrets from a point of view of what can be a threat here to you.
Excellent. Thank you, Kormaju. Excellent. So we've gone over what the world was like before Kubescape, and some of the basics of Kubescape and why it's a good starting point, and also just general threats in Kubernetes. And then we talked about 5 things that Kubescape can do, which are all pretty substantial. And it's I like that it uses the power of other projects that are under the hood, and then enriches what it does for this particular use case. So the experience of using Kubescape, is it just a matter of, it's a CLI tool and you just hey, here's my cluster, tell me about the vulnerabilities? What's that like?
So it's not. It has, I would say, three major interactions with the user. One is a CLI tool, which covers offline scanning of YAML files, Helm charts, images, which you would do maybe on your development machine, or your CI/CD or your scripts. And the CLI tool, you can scan also your cluster. But I wouldn't say that usually people tend to, they're not really using it for scanning clusters, but instead of CLI, they are installing, we have a microservice, an operator, which you can install inside your cluster, and it's monitoring the same data streams, but from within the cluster. And
so what I'm hearing is CLI tool scans your YAML and your Helm charts. It's good for CI/CD and good for development environments.
Yeah,
is that correct?
It's good for your dev machine and DevOps machine, and when you're trying to find out, you're investigating some specific issues and deep diving into them. It's good, but it's not a monitoring tool. It's more of I would say on per event basis tool. So when you have something to do right now, then CLI is great. And if you want to monitor your environment, you are installing Kubescape as a microservice in your Kubernetes cluster. And then it also you're opening a lot of potential there, because it's not just able to monitor your posture. So if you want to get a constant monitoring of what's happening in your environment, you can use it. But also it can tap into eBPF, and eBPF is I cannot use eBPF usually from the CLI that much. But
Okay.
collecting this information from the microservice in the environment and constantly monitoring your applications gives it a lot of potential to find out interesting things.
So when it's constantly monitoring your applications, do you get an alert if something comes up that is
so there are multiple options. So Kubescape, what it does in the cluster, it emits all the data, all its findings into Kubernetes CRDs, so Kubernetes API objects, which is a great thing because it enables anyone who wants to tap into this data, which is produced, can tap into that and start to use it and integrate itself with it. So it's a great open-end integration. But Kubescape also can offer a Prometheus exporter for exporting this information to Prometheus.
Cool.
And we have a Lens integration, a Kubernetes Lens integration. We have I think we have a Backstage integration as well for monitoring. So you can, but for example, in Prometheus, you can set up your own alert, your own alert rules if you want. So if you just giving you a very naive example, if you want to make sure that if you want to get notified about critical vulnerability, that's a workload that didn't have a critical vulnerability, but then for in the next scanning we find out that there is a new critical vulnerability, then you can set up your Prometheus stack to notify about that and take it into your Slack or into into anywhere. And we're not trying to solve that problem, right? So we don't
that's been solved.
That's been solved. So so these are way, and obviously we as Armo, we also have a support for a commercial offering for ingesting Kubescape information into a platform.
We have a couple of questions. One is from Kormaju. What is the CLO monitor? Is it part of Kubescape?
CLO monitor, no. If we're talking about the same thing as the CLO monitor, the only thing I know is making sure that your open source project stands in the best open source practices, and you have your best you have a code of conduct or you have your proper definitions of licenses and so on. So if we're talking about CNCF CLO monitor, then Kubescape is monitored by CLO monitor, but it's not used by the monitor.
Excellent. And then Varun's here. Hello, Varun. I'm so glad you're here. Varun says, when in the application life cycle do you recommend setting up the Kubescape operator?
So the Kubescape operator, I think that can be set up in any cluster, okay, for monitoring your environment from a security perspective and getting security posture, update security posture all the time. But if we're talking about application lifecycle, like sometimes or most of the times the Kubernetes cluster is already at the rightest side of your application lifecycle, right? Because this is where you're actually deploying things and running things. So if we are talking about the lifecycle as in software development lifecycle, so you're writing your code in your Vim or VS Code environment, and then you are creating a pull request and then pushing a container image into registry and so on. So a Kubescape has multiple integrations, so you can scan your YAML files and Helm charts already in VS Code and get some recommendations there. You can set up a GitHub action for saying that you are not ready to accept new risks and check the risk in a pull request, for example, and making sure that you have a quality gate there before nothing is entering even your Git before being checked or scanned by Kubescape. And you can also scan your GitHub repos and get a scanning of your GitHub repos and container registries with Kubescape. So all these parts of the life cycles are covered from at least from the things that we know to scan.
Cool. It seems super flexible. Varun has another great question. Do you think it's meant for a production cluster for live recommendations, or should people be using it in their live staging clusters? Ooh, apply the recommendations.
Love the question.
Yeah.
So I think Baron is like really touching into question of whether when we should generate the recommendations, right? Because maybe it's too late in the production cluster, right? But sometimes the production cluster is the only cluster which is used correctly in the way that it shows all the real use cases you have. So I think that Barun had in his question, he tried also to hint us that maybe it's better to solve that in the staging phases, and I totally agree with it. And for sure, we ourselves at Armor are using Kubescape in our staging environment, but we're also putting it in our production environment just to have a monitoring there, not really for getting recommendations of fixes, but more to just monitor all the vulnerabilities, because here I have to add that vulnerability scanning is a little bit different than configuration scanning, because in configuration scanning you have a given configuration and it doesn't change over time. But your container images, the vulnerability lists they are produced with the vulnerability scanner are changing over time. I don't know if you know that every day around 10,000 new vulnerabilities are added into the National Vulnerability Database, and this means that many, if you're scanning the same image one day after another, you might get a different results. More, you might get a more longer results, more vulnerabilities. Therefore, you have to monitor vulnerabilities. You have to monitor all the time, because if there is a new vulnerability disclosure and it turns out that from one day to another you have you get notified about critical vulnerabilities in your production cluster, it's something that you have to know about it. So I would say that recommend for fixing recommendations, most likely we'd like to do it before production, but you still have to monitor your production cluster anyhow. So you will end up using it both here and there.
That was a great question. All right. I liked thinking about config scanning versus vulnerability scanning, so I put that on the board. I have a question too, which is like one of my noob questions, but it is, what does it mean that it produces the finding as a CRD? So I understand a CRD is a custom resource. It can or cannot be paired with a controller to actually get work done on the cluster. So is the CRD just a method for delivery for textual information, or is it actually doing work?
So we are using. So okay. So when we decided that we want to store our results in CRDs, which is, I have to make here a little fix in what I've just said in a minute, but not in order not to complicate it too much, let's stay with the CRD definition. So we use CRD because CRD is an object of the Kubernetes API, and it's very good for anyone who's using Kubernetes. It's a very good way to create an open-ended integration. So if I'm putting my information, my objects, like a scan result of a workload is an object. If I'm putting it in the same API as they are already using, it's something that's very easy to integrate with. And
okay.
Very, very, like Kubernetes API already solves so many problems.
Okay.
Like access control, authentication, I don't know. So it's a very, 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 very neat way for us to store data for those who are using Kubernetes anyway. So they can tap very easily into the information stream. Now the fix. So we are not really using, like, we are using custom resources, but these custom resources are part of the functionality of the API server called API server extensions, which is a way to create Kubernetes custom resources which are not really stored by Kubernetes. So in this case, Kubernetes API server is a proxy which is the requests, and we are giving Kubernetes another microservice to work with, who is actually fulfilling these API requests, and Kubernetes is behaving as a proxy. And this is the way that we are, like, we are in a win-win situation, and I will explain why. Because Kubernetes CRDs are great for all the things I told you before, but they have a serious limit on their size. And not just they have a serious limit on their size, but they were never really meant to store different data, other data different than configurations. Therefore, they are limited in size, and they have their own, like, behavior and limits, and the way that they are stored and the way the API was constructed is very, very specific to, obviously, for the need of configurations. So there are other projects who started to use scanners, who started to use CRDs to emit their information, but after a while they found out that they might be overwhelming the Kubernetes API and etcds with the sheer size of their information. And this wasn't, I would say, it was something like trying to get a free ride on something that never was really, meant to bring such a heavy stuff with them. So therefore, the guys at Kubernetes came up with the idea of API server extensions, which is, again, it's a win-win situation, because on one hand you are getting all the good things which I told you before, with the authentication, authorization, and standardized API and open-ended integration. On the other hand, they are giving us the keys in order of the functionality of actually storing the information and keeping it right. So if we've invested in it, it took us a little bit more time, to be frank, but we wanted to make it right. So so we've wrote our own storage system. We had some good friends from other projects who helped us, from custom, or, like, obviously guys who know their stuff when we are talking about storage, and they helped us a little bit of what's the right way to do it. And we wrote our own implementation, so we are keeping this information inside the cluster in our own workload, but people can interface with us through the Kubernetes API.
Okay, amazing. Thank you for helping me understand that. That's very valuable. So I believe you said there were 3 ways to interface with Kubescape. Is that correct?
Sorry, I didn't get it.
Did you say there are 3 different ways to interface with Kubescape?
So the third one is I told it's somewhat an extension of CLI case. It's our GitHub action. So we are seeing a lot of use of our GitHub action, which is obviously integrating Kubescape into your GitHub workflows, scanning container images and scanning configuration files. And actually, our GitHub action is simply a wrap around our CLI.
Okay.
So but it's really been adapted to the use case of GitHub and CI/CD. But I think that we do have maybe something for GitLab, not maintained by us, but I think that someone also did an extension for GitLab. So I would put in the same use case. But they are also, what they are doing is actually, again, extending the CLI for this specific use case.
Okay. Cool. This is awesome. So, are there any other similar similar tools in the CNCF landscape?
So scanners, these kind of specific scanners is not really, I wouldn't say that. There are open source projects again, like Trivi is covering some of the use cases here as well. Again, Gripe itself is also a CNCF it's not a CNCF project, but also an open source project, and it's covering the image vulnerability scanning part as well. But I wouldn't say that this kind of specific scanner is not really like, within CNCF. I don't know, maybe I'm wrong, but I don't know of any other projects who are doing like this kind of scans.
Cool. Yeah, I don't either, but I was just asking. And then I have another question. Is this specific to Kubernetes, this tool?
So it's a vulnerability scanning part is not, but more or less all the others are very Kubernetes specific. So
Okay.
you can scan any kind of images. So we had here and there we are getting requests to extend Kubescape to scan also Terraform files for configuration, potential configuration threats. I can tell you that if there is anyone in the audience who would love to like contribute code, we are happy to. But I don't, up until now, we are the maintainers, didn't really have the, I would say, the courage maybe to go delve into that. But it shouldn't be really hard, but you have to know Terraform really well. So if there is someone who is with passion in security, I see Akash said that he would love to, and yeah, Akash, you're more than welcome.
Amazing, Akash. Yes. Thank you. That's cool.
So Akash, we are on the CNCF Slack, and you are more than welcome to like drop a message. And we are always really happy about new contributors. I think we had such a great year with contributors. We've joined forces with the Linux Foundation this year. We had mentees from its mentorship program, and I think it was a great initiative.
That's cool. There's a little bit of space left here. Maybe we can have one more vocabulary word to define. What would you like to say in this last little bit of area?
Wow, very very good vocabulary. I'm
seeing like attack vector, threat boundary.
I like, there is like those words in English where everyone is expected to understand that word, but actually you're right. Sometimes they need to be defined like posture. So I would say vulnerability. So
vulnerability,
So I would define it as I like to define it in a way that someone from the software development perspective, that it's a bug. It's a bug that in some cases might be exploited by an attacker to conduct an attack.
Oh, I like the in some cases. Because I just pretty recently learned that when you do a vulnerability scan, you have more vulnerabilities, like an overwhelming amount of vulnerabilities, and that most of them are throwaway, like they can't be exploited.
Yeah. So
yes,
it's a very hard thing, because first of all, vulnerability scanning is something that everyone does, and everyone hates. And it's not a real solution. It's only part of a solution. But actually it's something that most of the vulnerabilities, and we are going to incorporate this month something new into our vulnerability scanner, which is called EPSS. It's a scoring system by NVD and from other very smart people, which was invented in order to predict whether a vulnerability will be exploited in the near future.
Okay.
And which sounds like really like a strange definition, but it's actually a machine learning model to
Ah.
whether a vulnerability is really exploitable, and it's a probability number, so it's something between 0 and 1. uh,
Okay.
and I can tell you that like such a small percentage of the vulnerabilities are actually, from EPS's point of view, getting into the state where they can be like exploited within the next 30 days. And I also can tell you that Kubescape itself uses eBPF to understand which are the software components in the container that are loaded into the memory.
Mm-hmm.
And we are using this information to filter out from the scanner those vulnerabilities which are not loaded into the memory, which we are calling them vulnerabilities that are irrelevant.
Ah.
And I can tell you that sometimes it is 90% of the vulnerabilities can automatically thrown away. Uh,
Uh-huh.
and we are, again, this is something that we are very proud of, that we can lower the noise of the vulnerability scanners, um,
Mm-hmm.
because you're right, sometimes we are very overwhelmed with them.
Mm-hmm.
I just want to answer Barun.
Oh, hello to Napalm Codes too. Hi. Good to see you, friend. All right, Sparroon has another great question.
There is, so if you see at the beginning of the chat, there is a link to Armo's blog posts, and there are a few blog posts about the scoring system. I would suggest this is something that where you can get deeper. But if you're looking for EPSS, then it is something that I would like to really suggest you to read about. It's a very interesting thing. I like a little bit of self promotion here. I gave a talk last KubeCon about vulnerability management and all these new things in vulnerability management, like EPSS, relevancy, and stuff like that. And you can look up my name in the schedule of the last KubeCon, and the YouTube video is there. So it's a 20 minutes intro to all these scoring systems and the whole idea behind it. And I think it's a great video to start with. So
That's great. Cool. And what would you like to do with this last bit of space?
wow. Well,
No?
I would like. I'm really trying to think of what we can do here. I'm trying to think of what's going to come here to us in this year. I think that I would would add maybe admission controllers and admission policies, Kubernetes policies here. So
Okay.
Kubescape is, we've like from the very early days, we were asked by a lot of people, a lot of users, why we are not turning our rule set into admission controller. So
Mm-hmm.
why they can't use the same controls we are giving them as admission controller, and we had like this very we had a lot of dilemma here, because we didn't want, on one hand, the people asked for it. On the other hand, there are like two big projects in CNCF, Kyverno and Opa Gatekeeper, who are already
Yeah.
working on that. And
Mm-hmm.
it's not just that they're like, I mean, we have already 2-3 years behind it, and we didn't really feel that we have the the capacity and maybe even the ideas of what can we better with. So the only thing which we really see as something that is would be an advantage here is that people who are using us for posture management and finding out threats, and it would really make sense to turn the very same rules into policies, which was which made sense for us, but it really really didn't want to touch this thing. And a year ago, I started a sub project. Since Kubernetes itself started to incorporate new functionality, which is called admission policies. Admission policies are I would say a built-in, a very naive admission controller built inside into the Kubernetes API server.
Validating admission policy.
Yeah, exactly. Validating admission policies.
Yep.
And we created a project even before it became a beta feature.
As far as I know, it's still not beta. It's still alpha.
No, it's beta right now.
It is.
20, I think 128, but it is still under feature flag. So there, which is a big thing, because while it is under feature flag, it means that it's not available in big cloud vendors in managed Kubernetes. So it's a major, I would say, blocker. But we created a library of our Kubescape controls translated into the language of validating admission policies.
Cool.
So and it can be used, and again, we did it for like all our own, I would say, pleasure, or we wanted to play around with this, and we thought it would be a nice, we at least myself, I always like to, even when I'm learning something, I try to find some specific use case to learn on, and we created the CL admission policy library. CL because CL is the language of the validating admission policies. It's a rule language created by Google, and it goes for common expression language. And we translated most of our controls into that language, and we have a few folks who are already using it in their limited environments. And I think that this is something that when validating admission policies will go into be a real first-class Kubernetes citizen, then it will be very useful, because again, the people will be able to translate their posture threats into policies, not to let specific things into their cluster, into their namespaces, and it's a fun pet project. So so this is what I think that was really missing for some times, and we'll see how CL will progress. It's interesting.
So it'll help folks easily make policies that will
help you
improve their posture
and least privileges. Yeah.
Cool. That's awesome. I did a show about validating admission policy, so it's cool to hear it's beta, and it's really cool to hear it's being used. That's nice.
I think it's a really interesting initiative, because you think that admission controllers are already covering this problem space, but as it turns out, a lot of folks were complaining about the scalability issues with admission controllers, and validating admission policies, at least for very simple policy cases, is a good solution.
Cool.
obviously, like things like which are Kyverno and Gatekeeper are doing, like for example, just giving you an example, that validating the signatures of container images. This is not something that validating admission policies will cover, at least not in the in the short future. But I think that there are things that it does cover, and it's interesting thing.
Yeah, absolutely. And it's the Kyverno and OPA can like do resource cleanup and resource mutation. Like it's definitely those are mature technologies. Mm-hmm.
Yeah, very mature technologies. I agree with them.
But this is awesome too, and it's going to be great to have it like within Kubernetes. And like this is really interesting to me to hear a use case for it.
Yeah,
like this one.
Yeah, it's some kind of a side project, but yeah,
cool.
It's interesting.
Well, if anyone has any questions, now's the time. We have a couple comments. And then otherwise, I'm going to start in on our recap. Cell is really powerful. It is. But I learned during that other episode, it's not too powerful that it can be used to DDoS your cluster. And then Kuramashu says they're enlightened. If Kubernetes is not secure, then deploy Kubescape. That's great. It's especially since it's such an overwhelming field, it is nice to be like, here's a starting point, and here's how to at least cover your major bases right off the bat, and kind of have your hand held and be walked through it. I can see big value in that. So this is awesome. So what I'm going to do is I'm going to recap everything you've taught me. If I get something wrong, don't be afraid to interrupt me, because I don't want to. This is important to get this part right at the end. Okay, so back before Kubescape, there are starting to be standards for Kubernetes security, because it is a problem that everyone needs to solve. In fact, the NSA, National Security Agency, came out with security standards, and you, I guess, and your friends were like, there should be a tool that automates testing a cluster against these standards that already exist. And so that's how Kubescape was born. So it's a tool. Kubescape's a tool that helps you discover risks and threats in your system. I wonder if I should write best for Kubernetes.
Yeah.
We'll say, should we add it in your Kubernetes system?
Yeah.
In your Kubernetes system. So one thing that's great about security about Kubescape is it's a really good starting point for Kubernetes security, because it helps you solve configuration problems. It helps you filter out false vulnerability positives. It's really easy to use and to navigate, and it covers many aspects of security. We talked about threats and security in Kubernetes generally. Actually, before I get to the threats, let's go over some of the basic vocabulary that we touched. When many of us, or this just me, said, I don't understand that word. So to harden a cluster, to harden something, is to reduce the attack surface. So to make sure there are less possible exploits can be done. Security posture means like the risks and threats in the system are the posture. Least privilege means giving a human or a process the least possible amount of access for them to be able to do their job. And I also wrote, this is a hard problem, because it's if you don't give enough, then they can't do their job, and then that slows everything down. And then we talked about a vulnerability. A vulnerability is a bug that in some cases can be exploited by an attacker, but the in some cases part is important, because there are lots of distracting bugs that can't be exploited that are still vulnerabilities. So that's our vocab. And so threats in Kubernetes. So if you get a managed Kubernetes setup, which you almost certainly have one of those, you have good security as default. But the threats right now that are important are a supply chain attack. So like, for example, a build process exploit, or network vulnerabilities. So exploit the Kubernetes control plane, like an endpoint. I meant to write endpoint, and I wrote exploit.
Endpoint. And I just want to like a little bit of correction. So it's,
yes,
I would say that in maybe the thing that we didn't elaborate or maybe talked about it, but we didn't put enough emphasis on that. that managed Kubernetes has a good default setup. It's true for the infrastructure. Self-deployed Kubernetes cluster should also have a good level of default setup, but it has its pitfalls. So you still have to make sure that you're somewhat in the right place with it, and Kubescape is something that helps you with it, and the same goes for the NSA document and helps you to set up a cluster from the basics. But the reason why I wanted to return is that those threats we are talking about are threats also to manage Kubernetes clusters. They are not just I didn't want to state here that managed Kubernetes clusters are good as they are. The threats are also applicable both to managed and unmanaged clusters. Managed clusters has some of the security threats coming with the Kubernetes setup are taken off your shoulders by using a managed cluster, which is more or less, the infrastructure setup, the TLS and certificate management between Kubernetes nodes, and all of these things that can be automatized, and they did a good job of getting rid of all these kind of structural problems. But the threats are also existing there, these threats which we talked about.
Excellent. So these threats are for managed Kubernetes and for self-deployed Kubernetes. But these are currently the main two attack vectors in the system. So then we talked about Kubescape generally, and Kubescape can do a lot. We talked about 5 main things. So Kubescape can scan Kubernetes infrastructure setup. So the configuration for that. So like the control plane configuration, kubelet configuration, cloud provider, API configuration. So examples would be like it would scan for whether the Kube API server uses TLS, and it would scan for whether the secrets are encrypted at rest and etcd. It also can scan your workload configuration. So now we're talking about application level. So it's going to scan like whether your workload's being run as roots. And it's going to scan things like permissions and things at the file system level and things at the kernel level. So it's looking all over the place at what your application, your workloads are doing. It can also scan for your rollback base access control, your RBAC configuration, to ensure least privilege access. One of the things we talked about.
Yeah.
So it also does vulnerability scanning on workloads. Now, we talked about the difference between configuration scanning, which these 3 are, and vulnerability scanning. Configuration scanning is kind of one and done because your configuration, once you set it up, is unlikely to change. But the vulnerability scanning, the possible vulnerabilities in the world are changing all the time as people are figuring out how to exploit stuff. So this needs constant monitoring.
Right.
And then Kubescape does this vulnerability scanning in workloads, but it does both container images and actual running workloads. And it uses another CNCF project called Gripe under the hood to do the heavy lifting, but then Kubescape enriches the data. And one thing we talked to, what's that?
Yeah, sorry, Gripe is not a CNCF project.
Oh, okay.
Inspector Gadget is.
Okay, I got it mixed up. So Gripe, but it is open source.
Right.
And so, but one thing we talked about with the vulnerabilities is one thing that Kubescape does is it knows which vulnerabilities are exploitable and which ones are not. So it filters out the non-exploitable ones, so you don't have to worry your pretty little head about stuff that doesn't matter, which is important.
Very important.
Yes, for everyone's head, regardless of size or attractiveness. So then, besides the vulnerability scanning, then the last thing it does, number 5, is that it gives proposals for hardening and remediation, which is a big deal. So it's not only telling you everything that's wrong, it's also telling you some possible solutions for the things that are wrong. So for this one, it uses the CNCF project, Inspector Gadget. And Inspector Gadget has eBPF-powered observability. So it's able to watch everything that's happening at the kernel level. And then, for example, example of remediation proposal might be, Kubescape might give you a least privileged network policy proposal.
Right.
So that's Kubescape can do a lot. The other thing is for the config scanning, Kubescape uses OPA, Open Policy Agent, with their own rules.
Right.
So then we talked about the Kubescape. Oh, you look like what?
Yeah, just one thing, which is Inspector Gadget. The project uses, instead of C, it uses a K. Like in everything that is going into Kubernetes, it's an inspector with a K.
Oh, awesome. I love how great. K. Inspector Gadget. Thank you. Awesome. And so for Kubescape user experience, there are 3 ways you could interface with Kubescape. One, you could use the CLI to scan your YAML or scan your Helm charts. It's good for the CLI, it's good for CI/CD, and it's good for when you're investigating issues. Then you also have a Kubescape operator, which installs Kubescape as a microservice, and then you can constantly monitor your security posture. This uses eBPF. It produces the findings as CRDs, so then you can incorporate them easily, integrate them easily with other projects, such as Prometheus Exporter, for example, if you want to maybe be alerted when certain things happen.
Right.
And then finally, we have the GitHub action as a way to interface with Kubescape, which is really just a wrapper for the CLI, but you can integrate Kubescape into GitHub. Right. And then you said Kubescape doesn't manage it, but GitLab has an integration for Kubescape too.
Yeah.
And then finally, as part of scanning for these configuration problems, there's been a demand to have rules that admission controller rules for what should be allowed in the cluster that Kubescape produces. And so finally, that's starting to happen because Kubescape, for funsies, created a library of Kubernetes validating admission policies, which is a new object in Kubernetes. It's beta. What's the feature? How do you talk about the feature flag?
It's a feature flag. It's under feature flag in the API server. The API server has a concept called feature flags, which is just like in any other tools. And when you're starting up the API server, you can either enable or disable it. Now, within your own Kubernetes cluster, you can enable it. But when someone else manages the API server for you, then it's a kind of, depending on him, whether you can use it or not. And as far as I know, even in 1.29, it's still closed by the major vendors, as far as I know.
Okay, but so if you have a Kubernetes cluster version 1.28 or newer, then you can enable this feature flag if it's not already enabled to be able to use validating admission policies. Right. These are written, both the Kubescape ones and any validating admission policy is written in common expression language, which is abbreviated as CEL. And basically, the Kubescape project is helping folks make policies that will easily make policies that will improve security posture and least privilege access.
Yeah, cool.
You feel good about that? We did it.
Yeah, it's awesome.
Thanks, everyone, for coming. I don't know if you watched the episodes you watched until the bitter ends, but we're going to dance a little bit at the end. I'm going to replay the music. All you have to do is some like this. It doesn't even matter.
I will try to. I haven't tried that. But now I'm going to review everyone.
So we're just going to say goodbye. Time for the dancing. Everyone's excited. Bye, everyone. Thanks for coming. Thanks for the wonderful questions. Thank you, Ben, for sharing your expertise with us. You're the best. Yeah. That's great dancing. You got it. You're doing it. Yes. Heck yeah. Bye.
Bye.